Hello there. Today we are going to take our knowledge about solving systems by graphing and mix that up with our conic section. So before we were just doing quadratics and lines, but now we're stepping it up and we're going to be looking at our conic sections and solving systems of our conics. So our first step for solving these systems is to look at our equations and say, well, what should these graphs look like? So we've talked about this already, since our x is squared and our y is squared, and it has the same coefficient, the same number in front, and it's an addition sign. We know this is going to be a circle. And then for our second equation, if we're looking, we have our x and y both squared, but it has different coefficients, and it is addition in between. So we know our second equation is going to be an ellipse. Okay? Figuring out what each of the equations are will help you for when we do our later steps. So this should be your first step every time, so you know what to expect on your graphs. Now I know in class I said we can't put some of these in our calculators, but that is only in this form. We can't put all of this straight into our calculator. If we wanted to do that, we would have to get y by itself. So that's what we're going to do. We'll be using our graphing calculator all throughout this lesson and in class. So if you don't have it out already, pause the video and get your graphing calculator out. Okay? So our first step, or our second step, I guess, when we are doing this, we need to get y by itself. So if we're working with our circle equation, we have x squared plus y squared minus 16x equals negative 39. We need to get our y by itself, so let's move everything else to the other side. So we'll have y squared equals negative x squared plus 16x minus 39. And our y is being squared. To undo that, we take the square root of both sides. And remember, when we take the square root of something that's squared, it leaves it by itself, but then that gives us a positive and a negative answer for your right. So you'll have plus or minus the square root of negative x squared plus 16x minus 39. Now with this, we don't have to simplify it at all. We can leave it as is, okay? But when we go to put this into our calculator, there's no button for this plus or minus. So like I said, it gives you two solutions, your positive and your negative solution. So when we enter this into our calculator, we're going to have into our y1, we're going to put the square root of negative x squared plus 16x minus 39. And then into our y2, we're going to put negative square root of negative x squared plus 16x minus 39. Alright, so that's just for our circle equation. Now we're going to do the same thing for our ellipse equation. Okay, so we have 5x squared plus 9y squared equals 161. So again, get everything else but your y's on one side. So you'll have 9y squared equals negative 5x squared plus 161. To get our y squared by itself, we divide both sides by 9. So we're left with y squared equals negative 5x squared plus 161 all over 9. And again, take the square root of both sides. So we're left with y equals plus or minus the square root of negative 5x squared plus 161 all over 9. Now, your gut may be telling you, ooh, I can simplify this. The square root of 9 is 3. But we're just entering this into our calculator, so we don't have to simplify this at all. We can leave this as is. So, but we need to separate our two equations. So we're going to have our one equation. This is going to be our y3. 1, 2, 3. Third equation, we're going to have that as negative 5x squared plus 161 over 9. And then our y4 is going to be negative square root of negative 5x squared plus 161 all over 9. Whew. So we have our 4 equations here, and we need to put these into our calculator, and just like we did before when we were solving systems by graphing, we need to see their intersection points. Okay, so if we get our calculator out, I'll move it on the screen so you can see. So we first have to get to our y equals, so when we do that, it'll look something like this. So let's put in our first equation. So we have the square root of negative, make sure you're putting the negative and not the minus sign, negative x squared plus 16x minus 39. We don't have to worry about closing the parentheses. And for our y2, we're going to have our negative x squared plus 16x minus 39. Now, what I want you to do for your y3 and your y4 is, before you enter those in, is to move over to the left and make your cursor on this line so it's flashing. You should hit the left button twice, then hit the enter button. This will help us on our graph to distinguish between our two graphs, our two conic sections. And then let's hit down, and then we're going to do the same thing for our y4. Okay? So if we go back to our y3, so again, our y1 and y2, that's our same conic section, that's our circle. Now our y3 and y4, this is going to be our ellipse. Okay, so let's fill in what our y3 is here. Now, since this is a fraction, what we need to do is we need to put parentheses around our numerators, okay, because our calculators are pretty smart. So we need to make sure that it knows that this negative 5x squared plus 161 is all in the numerator and the 9 is in the denominator. So we need to add parentheses there and add parentheses for our y4 equation as well. So make sure you have your second set of parentheses there. Now, I should probably mention this. Depending on what kind of calculator you have, your formatting may be slightly different, but it never hurts to have an extra set of parentheses in there. So I would do this just in case. Okay, so add your second parenthesis there, and you should have negative 5x squared plus 161. And close your parenthesis for your numerator. And that's all over 9. And then let's go down to our y4. So we should have negative square root of parenthesis, negative 5x squared plus 161, close our parenthesis, divided by 9. Alright, and as we try to look at these graphs, we need to make sure that our window is in its standard form. So if we go to zoom, let's just go to our option number 6, Z standard, and take a look at what this looks like. So there is our circle, and there is our ellipse. So you can clearly see the difference between the two. Now, but we can't really see our circle, so let's make our window a little bit longer in the Y direction. Sorry, in the X direction. Woo. So let's make this a 15 instead, just to spread it out a little bit. And let's hit graph again. There we go, we could see it all now. So again, this is our circle graph, and this is our ellipse graph. Our circle doesn't really look like a circle, but that's only because our scale isn't the same. If we had the same number of x's as we did y's, it would look exactly like a circle, but we don't. It's okay, we know this is our circle equation. So our answer for this, if we were to solve our systems, we would be looking at these intersection points, right? So what we're going to do is try to sketch these graphs, but we need to figure out what these points are. So to do that, we're going to have to go to Second, Trace, and we want to hit our option number 5 for Intersect. Okay, so it'll say first curve, and it tells you which curve it's on. It says it's on Y1 at top left, so that means it's on this curve here. So let's see if we could find our cursor. There it is. So first curve. Yep, so as long as we could see it, we're on it. Oh, it's moving. Oh. Not sure what's happening. Well, that was weird. I don't know what was happening. But anyway, so we're on our first curve. Now we see our cursor. Once we do that, we hit enter. And then it'll automatically go to our second curve. So now it's on our Y2, but we don't want it on our Y2. We want to see where it intersects up here. So in order to switch from curve to curve, from equation to equation, we would use our up and down buttons. So if we hit down, that'll get us on the line or the equation that we want it to be on, so Y3. So now it's on the right curve. We can hit enter. And now it wants us to guess. So now we can just move a little bit towards where we think the intersection point is, and we hit enter. And it gives us an intersection point of 4, 3. So we can graph that on our graph here. So we have 4, 3. Okay. So then let's find our second intersection point down below. So we do the same thing, second trace. Choose our option number 5, and we want it to be on our Y3 now, or our Y2 now, excuse me, to look at this intersection point. So just to make sure, yep, we are on our Y2, so we can hit enter. Now it'll jump to Y3 for our third curve, but we want it to be on our Y4, this lower curve here. So you can see it's on Y4, so you can hit enter, and then guess. Just move it somewhat closer to your intersection point, and you hit enter. And it'll give you your intersection point of 4, -3. So we can plot that on our graph. 4, -3. Okay? So we need to be able to sketch this graph, though. So at this point, let's sketch the graph of these two conic sections. So let's do our circle first. So if we just count where our x-intercepts are for this, we have one at 1, 2, 3, and we have one at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we'll have to make a few more tick marks on our graph. So let's do that. We have one here, and we have, this is 10, 11, 12, 13. So we know the graph of our circle is going to look something like this. Rough circle. Okay. And then for our ellipse, we know it'll intersect somewhere 1, 2, 3, 4, 5, roughly in the 6th region, and 1, 2, 3, 4, 5, 6, 7, 8 region between there. So if we make a point at 6, make a point in between 7 and 8, and we can look to see what our y-intercept is. 1, 2, 3, 4, up 4, and 1, 2, 3, 4, 5, roughly, -5. So it's going to be up at 4 and down to -5. So our ellipse is going to look something like this. Whoop. Okay, that was rough, but so it shows that these two are our points, which would be the answer for this first problem. So this is going to be 4, 3, and 4, -3. Okay, so I need you to go to the Moodle page and click on the part 2 for the video so we can do the second problem.